Okay, Nidhi. Hello. So, mali start on first name ikkada nunchi. So, this is the definition of polymer, and polymer means it is a Greek word actually. It is derived from the Greek word poly in the sense many, mer means unit. So, poly means so, definition, understanding the definition is very important. Now this is polymer, and myself Chandra Prakash from Ecet coaching institute, that is Ask Engineering Academy, Dilsukhnagar, and today we are going to discuss about polymer. Already I have explained what are the contents in the polymers itself. This is polymer. Polymer, it is a Greek word actually, it is a Greek language word. So, polymer is a word which is formed by the combination of two different words. It includes polymer. What is meant by poly? Poly in the sense many, mer in the sense unit. Now see, polymer is a Greek word that contains two components. One is poly, one is mer. Poly in the sense many, units. That means polymer is defined as it is a giant molecule or macromolecule which is formed by the linking of many repeating units. For example, it is generally defined as it is a macromolecule, macro in the sense huge molecule with high molecular weight. It is a macromolecule generally formed. It is a macromolecule generally formed by linking of millions or thousands or hundreds, millions of small units, which are called as monomers. Mer, unit, millions, monomers, millions of small units called as monomers. Next, now I think you are get an idea about polymer. Polymer is nothing but it is a large molecule which is formed by linking of many millions of monomers together. One monomer, like this chain, like linking. By the linking of all the monomeric units, finally one product will be get. That product is called as polymer. Polymer is nothing but it is a combination of millions of monomer units, that is called as polymer. And now the process of formation of polymer is called as polymerization. Simply, one monomer is attaching with one another monomer. This process is called as the process through which the monomers are linking with each other. This process is called as polymerization. That means process of formation of monomers or polymers. Process of formation of polymers is called as polymerization. I think now you get an idea about what is meant by polymer, what is meant by monomer. Monomer is nothing but it is single unit. Monomer is a single unit. Unit is called as monomer. These are important terms you must remember while you are dealing with polymers. One is polymer, monomer. Without monomer there is no polymer, because monomers combine together to form giant molecules, that is called as polymer. The process is called as polymerization. Now that is called polymerization. For example, For polymerization, I will give an example for you. See, I will give a small example for you. Example for polymerization, polythene. Polythene is an example for polymer. Polythene is an example for polymer. This polythene is generally formed by many monomer units called as ethene. Ethene ane monomer units combine avvadam valla form ayinde polythene. Ethene, for example, C double bond C. This is ethene. This is ethene. We are taking this ethene molecule. See, ethene means 2 carbons, 4 hydrogens, double bond, ethene or ethylene antam deenni. N number of, we are taking N, many number of ethene molecules. So this number of molecules undergoing polymerization process. Undergoing polymerization process. As a result of polymerization, this double bond will gets broken and forms as large molecule with the same number of units called as polymer. That is, now the double bond will be broke and single bond will be formed same as it is. Now this is polythene. N comes here. Now see, this is monomer. Monomer, that is ethene. As a result of polymerization, it forms as polythene. See, monomer, polymerization, polythene. Monomer units are n number of monomers combined together, double bond will get broken and n number of polythene will be formed. This is a huge molecular weight compound. This is how polymerization generally happens. Now, types of polymerization, how the polymerizations are categorized into many types. And before this, we have to know about what are the different types of polymers also. Polymerization is very important, but how many different types of polymers are also there, which are divided based on the type of monomer unit present in it. For example, see, these polymers are classified into two types depending upon, based on monomer units, based on monomer units. See, polymers are again classified into two types based on monomer units. Those two types are called as, one is homopolymers. Second one is copolymers. Homopolymers and copolymer. What is meant by homopolymer? Homopolymer is one of the class of polymer in which there is only one type of monomer unit. This is a polymer, but it is formed by interlinking of only one type of monomer unit. For example, M gives rise to M power N. This is a polymer. Only one type monomer, M type of monomer, all are M's because there is single type of monomer units. So this is called as homopolymer. Copolymer in the sense different types of monomer units combined to form a monomer. In this case, different types there, M1, M2, M1, M2. Here see, two types of monomer units are combining. Because of combination of two different types of monomer units, this is called as copolymers. This is called homopolymers. These are the two important things. And one more classification is also there. This is based on monomer units. Another classification is based on structure of polymer. It is based on one classification. Second classification is based on structure. Based on structure of polymers. Again, it divides into mainly four types: linear, branched, third cross-link, and fourth one is graft polymers. See, based on the structure of polymers, again the polymers are divided into 4 different types: linear, branch, cross-link, graft polymers. What is linear polymer? Linear polymer is simply the polymer is in straight chain, or the monomer units are arranged in straight chain like this. M, or they are arranged in one single straight chain. So it is called linear. Branched in the sense, for example, this is M, this is M, this is M, this is M. This is the parent chain. అంటే మెయిన్ చైన్ అనేది పేరెంట్ చైన్ అంటాం. పేరెంట్ చైన్కి అగైన్ కన్సిస్ట్ ఆఫ్ బ్రాంచ్ లైక్ దిస్. సో ఇఫ్ ఇలా ఉంటే దీన్ని ఏమంటారంటే బ్రాంచ్డ్ పాలిమర్స్ అంటారు. క్రాస్ లింకింగ్ పాలిమర్స్ అంటే ఏంటంటే మోర్ దెన్ వన్ బ్రాంచ్, చాలా బ్రాంచెస్ ఉంటాయి దాంట్లో. ఇక్కడ ఒక బ్రాంచ్, ఇక్కడ ఒక బ్రాంచ్, ఇక్కడ ఒక బ్రాంచ్ ఉంటే మెనీ కైండ్స్ ఆఫ్ బ్రాంచెస్ ఆర్ ఇంటర్లింకింగ్ టు ది పేరెంట్ చైన్ ఈస్ కాల్డ్ యాజ్ క్రాస్ లింక్ పాలిమర్స్. One thing you must notice here is the monomer units in parent chain, the monomer units in branched chain are similar, all are M. But in the case of graft polymer, it is completely different. In the graft polymer, this kind of diagram will be there. M, 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 M. This is one chain, which is parent chain. The branched chain will be like this: M1, M2, M1, M2. Here the parent chain is one type, here the daughter chain or branch chain is another type. These kind of polymers are called as graft polymers. Graft polymers are nothing but the polymers in which two different types of monomer units present. One type is existing in straight chain, that is parent chain, another type is present in branch chain. This is called as graft polymers. This is all about a reaction. It is a reaction that yields the products, that yields one product. It is a chemical reaction that yields one product that contains multiple of monomer units of original one. Monomer units of original one. That means addition polymerization is nothing but is a reaction between monomers in which addition of all the monomer units and one product will be produced, that is polymer. Addition polymer and andan. That addition polymer contains the monomer units which are approximately equal to multiplication of monomers which are present in the original product. Original compound lo unna monomer units anni multiply cheste enna avutayo anni monomer units ee product lo untayi. This is called as addition polymerization. And one more thing, the monomer unit, the monomer which is used in this addition polymerization must contains one or more double bonds. This is important thing. The monomer contains at least one or more double bonds. In this polymerization, monomer units are there. That monomer units, the molecules which are acting as monomer units in this process, must contain one or more than one double bond in its structure. And also, this is a reaction generally performed in certain conditions. In the presence of light, pressure, and in the presence of catalysts. These are the 3 important parameters where the addition polymerization generally happens. By using this energy, the double bond of the monomer unit will be broken into parts and it leads to the formation of polymer. The best example for this is formation of polythene. Formation of polythene is the best example for this. Example, polythene formation. For example, this is ethene. I already said this is a monomer unit. It contains one double bond. This is monomer unit. In the presence of polymerization, this is addition polymerization. In the presence of light, pressure, catalyst. So in the presence of light pressure catalyst, this bond will be undergoes rearrangement. అంటే ఇక్కడ ఉన్న బాండ్ అనేది దాని పొజిషన్ నుండి వేరే దగ్గరికి రీఅరేంజ్ అయిపోతుంది. దిస్ ఈజ్ కాల్డ్ యాజ్ rearrangement, undergoes rearrangement, so leads to the formation of polythene, and single bond double bond will be broken and form into single bond. Now here n will be there. This is called as polythene. Now ethene converts into addition polymerization in the presence of light pressure catalyst to form polythene. So this is how addition polymerization usually happens. This is called as polymerization, that is addition. It is a reaction that yields product, and conditions are light pressure catalyst. It must contain, monomer unit must contain at least one double bond. That double bond will be broken by process called as rearrangement in the presence of energy of light pressure catalyst. So this is all about addition polymerization. Next, condensation polymerization. Now we are moving on to condensation polymerization. Condensation polymerization is also a chemical reaction, but that reaction is between monomer units that contain polar organic groups. It is chemical reaction. It's a chemical reaction between polar groups, of two different monomers. That means two different monomers will combine. That two monomer units must contain different polar groups. I will explain how. Groups of two different monomers, and there is elimination of water. There is simple elimination of water or HCl molecules. So it is a reaction in which it is a reaction between two monomer units. One monomer contains one different kind of polar group, one monomer unit contains other kind of polar groups. There is a reaction between these two polar groups. At the end of the reaction, certain kind of simple molecules such as water, HCl, ammonia can be eliminated. By the elimination of simple molecules such as water, the product is formed, that is called as condensation polymer. That is called as condensation polymer. The best example for this is, the best example for the polymer which is formed by this method is nylon 66. Example, nylon 66. Nylon 66 is a polymer which is a condensed polymer which is formed as a result of condensation polymerase. It is generally formed between the reaction between adipic acid plus hexamethyl diamine H. This is amine, and now this is amine. Now this is H. See, clearly see. This is hexamethylene diamine. Hexamethylene means 6 hexamethyl groups. Diamine, here also NH. See, NH2, one amine, CH2 hexamethylene, another amine, diamine. So this is, it will looks like. Now it reacts with adipic acid. Adipic acid in the sense, here in place of 6, only tetramethyl will be there in this. There is only tetramethyl. Here CH2 4. Now here C double bond OH, C double bond OH. Now the removal of water molecule will happen. This is a structure of adipic acid. This is a structure of hexamethylene diamine. Removal of water molecule will be takes place. Here removal of water molecules like this. Removal of water molecule will be usually happens minus H2O. Then the formed product is called as nylon 6,6. So this is adipic acid, hexamethylene. By removal of HOH from the two molecules, the formed product is nylon 6,6. So this is all about condensation polymerization. Plastics, in the sense, plastics, we know very much familiar with the word plastic. Plastic are the high molecular weight organic molecules. Plastics are defined as high molecular weight organic molecules with organic functional groups which can be molded into desired shape. అంటే పాలిమర్స్ అనేవి ఆర్గానిక్ మాలిక్యూల్స్తో ఫామ్ అవుతాయి. అవి ఎలా అంటే అలా మనం షేప్స్కి కన్వర్ట్ చేయొచ్చు. వీ కెన్ కన్వర్ట్ దెమ్ ఇంటూ వాట్ ఎవర్ ద షేప్ వీ వాంట్స్. మనకి ఎలాంటి షేప్ అయితే కావాలో అలాంటి షేప్కి దాన్ని మౌల్డ్ చేయొచ్చు బై సింపుల్ అప్లయింగ్ ప్రెషర్ ఆర్ అప్లయింగ్ టెంపరేచర్. బై కూలింగ్ ఆర్ బై హీటింగ్ వీ కెన్ మౌల్డ్. సో డెఫినేషన్ ఈజ్ యాజ్ ఫాలోస్. Organic materials, these are organic materials which can be molded, molded in the sense we can change it shape, molded into desired shape, on heating, on simple heating or cooling. This is called as plastics, and there are basically, this is a basic definition of plastics. Now there are different types of plastics are there. So there are mainly two types of plastics are there, depends upon physical properties. Based on physical properties of plastics, they are divided into two different types. Two different types of plastics are there. Based on the physical properties of the plastics are mainly classified into two different types. First type is type 1, thermoplastics. Second types are thermosetting plastics. Thermoplastic, thermosetting plastic. These are the two types of plastics based on physical properties. Thermoplastic, the best examples are thermoplastic, polythene, polyvinyl PVC, and LDPE, HDPE. These are the best examples for thermoplastics. Thermosetting plastic examples are bakelite. These are different types of bakelite is a basic example for thermosetting. How the thermoplastics properties there? Thermoplastics are the plastics which can be molded according to their shape and size whatever we want. It can be reprocessed. అంటే ఈ ప్లాస్టిక్ ఎలా అయినా మనం చేంజ్ చేసుకోవచ్చు మన అవసరాల నిమిత్తం. అంటే అకార్డింగ్ టు అవర్ నీడ్స్, అకార్డింగ్ టు అవర్ యూసేజ్ వీ కెన్ మ్యానిపులేట్ ద స్ట్రక్చర్ ఆఫ్ plastic. Those plastics are called thermoplastics. It can be reprocessed. But thermosetting plastic is not able to reprocess. It cannot be reprocessed because very hard plastic. So it cannot be reprocessed. Can't be reprocessed. So this is all about types of plastics based on physical properties. Thermoplastic, thermosetting. Under thermoplastic, polyethylene, polyvinyl chloride, LDPE, HDPE are the examples. In thermosetting, bakelite is an example. These are the different types of plastics. Next, advantages of plastics over traditional materials. Advantages of plastics over traditional materials. Now we are using plastics by replacing ట్రెడిషనల్ మెథడ్స్ వాట్ అవర్ ఏన్షియంట్ పీపుల్ మన పూర్వీకులు ఏదైతే మనకి ఇచ్చారో మన ఫాదర్స్ అవన్నీ రిప్లేస్ చేసి మనం ప్లాస్టిక్స్ వాడుతూ ఉన్నాం. మరి ఏంటి ప్లాస్టిక్ అడ్వాంటేజెస్ ఏంటి ట్రెడిషనల్ మెటీరియల్స్ రిప్లేస్ చేయడం వల్ల? వాట్ ఆర్ ద అప్లికేషన్స్ ఆఫ్ ప్లాస్టిక్? ఫస్ట్ అండ్ ఫార్మోస్ట్ ఈజ్ I will give you at least 5 advantages. First is lightness. The plastics are very lighter, so easy to carry. One advantage is the plastics are very lightweight. So they are lightweight, moreover they have intricate cross linking, but they are lightweight, so we can easily carry them. So it is one of the advantage. Second one is it act as good thermal and electrical insulators. Good thermal and electrical insulators. So plastic, one of the main applications of using plastic is we are using electronic devices. So we are using plastic in that because they are good thermal insulators, because through the plastic current will not pass. Current అనేది దాంట్లో పాస్ కాదు, అంటే కరెంట్ షాక్ని తగ్గించడం కోసం electronic devices are generally made up of these kind of plastic which are good insulator in the sense that is not allows the current, which is a reciprocal of conductors, insulators. And third one is corrosion resistance. Corrosion resistance in the sense plastics are the materials which one of the very important material which cannot undergoes a process called as corrosion. Corrosion ante entante rusting antam manam. Iron is the metal. If you use iron in the electronic devices, it is a good conductor of electricity. It is a corrosive material. So iron is replaced by plastic. It is an insulator at the same time anti-corrosive. Avi jangu pattadam lantivi jaragadu. So it is called as corrosive resistance. And impermeable to water. Impermeable to water. That means if for example plastic bottles, we are using water bottles. So that water bottles, in the water bottle the water is impermeable, ante plastic nundi travel cheyadu water. So impermeable, not permeable through the bottle. So this is one of the advantage. And next, toughness. Plastics are moreover lightweight, but they are very tough. It is cannot be teared or torn. It is very difficult because of close linking polymers. Close linking polymers ఉండడం వల్ల plastics are high materials with more tensile strength. Tensile strength ఎక్కువ ఉండడం వల్ల plastics కి toughness ఎక్కువ ఉంటుంది. So it is not easy to break it because of much more toughness. One this, and high refractive index. It is also one of the advantage, that is high refractive index. It is one of the properties of materials. So these six are the important advantage of plastic over traditional materials. Traditional materials వాడడం వల్ల మనకి ఇట్లాంటి అడ్వాంటేజ్ ఉండవు, బట్ ప్లాస్టిక్స్ వాడడం వల్ల ఇవన్నీ అడ్వాంటేజ్ ఉంటాయి బేసికల్లీ. Now we are moving on to disadvantages of using plastics. There are some, for example, for any materials there are advantages and also disadvantages. So far we have discussed various advantages of plastic. Now we are moving on to disadvantages. What is the disadvantages of using plastics? First, high costs. The plastic cost is huge. High cost is one of the disadvantage. Next, combustibility. Combustibility in the sense, high combustibility in the sense it can catch fire very easily. మంట పెట్టినప్పుడు ఈజీగా అది క్యాచ్ చేస్తుంది. దిస్ ఈజ్ కాల్డ్ as కంబషన్, బర్నింగ్ అంటాం. సో కంబస్టిబిలిటీ. నెక్స్ట్, డిఫార్మేషన్. డిఫార్మేషన్ అండర్ లోడ్. అంటే డిఫార్మేషన్ ఇన్ ద సెన్స్, ఫర్ ఎగ్జాంపుల్ వాటర్ బాటిల్. when we apply any kind of pressure on water bottle, the shape of the water bottle will deform. అంటే షేప్ అనేది కోల్పోతుంది. It can lose its shape. This is nothing but deformation under load. Whenever we apply particular kind of pressure from the load, the normal initial shape of the plastic can get altered, change అయిపోతూ ఉంటుంది. That is called as deformation under load. Now, softness. The plastics are tougher, at the same time they are much more softer. Because of excessive softness, certain kind of shelf life of the plastic can be reduced. Shelf life అంటే ఏంటంటే దాని యొక్క వ్యాలిడిటీ ఏదైతే ఉంటుందో తగ్గిపోతుంది, ఎందుకంటే అవి ఎక్సెసివ్గా సాఫ్ట్గా ఉంటాయి. సో దీస్ ఆర్ ద డిసడ్వాంటేజెస్ ఆఫ్ యూజింగ్ ప్లాస్టిక్. అండ్ వన్ మోర్ ఇంపార్టెంట్ థింగ్ ఈజ్ ఇట్ కెనాట్ బి డిగ్రేడెడ్ ఈజీలీ. ఇట్ కెనాట్ బి degraded easily. Plastic cannot be degraded. Whenever we throw plastics in the soil, in order to degrade itself, it takes millions years of time to degrade itself. So it is one of the major causes of soil pollution also. So these are the disadvantages of using plastics. Now preparations and use of some important plastics which are using in the daily life, which are very important to us. Now, so far we have discussed different types of plastics and various types of plastics, types of polymerizations. Now we are moving into preparation, properties and uses of different plastics. In that, first one is polythene. First it is polythene. Polythene is an example for plastic which is very important and which is generally used many times in our daily life. Polythene covers and all this. In that, polymer is polythene. Polythene preparation generally depends upon, it is basically formed by the polymerization of ethylene. Ethylene ane molecule polymerize avadam valla idi form avutu untundi. So it is generally formed preparation from polymerization of ethylene. Already I explained it, polymerization of ethylene. So polythene is generally formed from polymerization of ethylene monomer. Generally ethylene exists as gas. Generally natural ethylene is a gas form. It exists as gas. This gas will be converted into liquid. Then a liquefaction and liquid. This process is called as liquefaction. Gas liquid under high pressure, approximately 1500 atmosphere pressure. The gas is converted into liquid under high pressure, that is 1500 atmosphere. Once the gas is converted into liquid, the liquid again pumped into hot steel vessel whose temperature approximately 250 to 300 degrees centigrade temperature. 250 to 300 degrees centigrade temperatures. In the presence of O2, oxygen as catalyst. See, polythene can be prepared from polymerization of ethylene, which is generally gas. It is converted into, first step enti ikkada. First step is converts into liquid under high pressure 1500. Again this is pumped into hot steel vessel which has temperatures of about 250 to 300 in the presence of O2 catalyst. Final goche product vachesi this is polythene. This is polythene. Generally the polythene is properties. Properties in the sense, what are the parameters and how the polythene will be classified. Polythene is generally waxy in nature. The waxy in the sense, మన క్యాండిల్ ఉంటుంది చూడండి వ్యాక్సీగా, అలాంటి మెటీరియల్ ఫామ్ అవుతుంది అన్నమాట ఇనీషియల్గా. ఎట్ ద ఎండ్ ఆఫ్ ఫార్మేషన్ ఆఫ్ పాలిథిన్ ఇట్ ఈస్ జనరల్లీ సెన్సిటెడ్ యాజ్ waxy in nature. Waxy in nature. Next, it is translucent. Translucent, that means we have materials transparent, opaque and translucent. Transparent means mirror. We can see easily the outer and front area and outer area is very clearly. The transparent. Opaque means oil paper. We cannot see through them. But translucent means somewhat transparent, somewhat opaque. That is called as translucent. So polythene is a translucent material because it cannot be pass light or it cannot see clearly as we thought. It is called translucent materials and it is generally non-polar in nature. Generally non-polar in nature. And these polythene are again classified into two types. Low density polythene LDPE, high density polythene HDPE. Polythene are again classified into two types. Low density polythene, high density polythene, LDPE and HDPE. Now we have preparation completed, properties completed. Now uses. Uses in the sense, I am writing uses here. Please make note of it. Uses in the sense for making bottles, water bottles simply, pipes, bags, toys, children toys. So the polythene is generally used for the manufacturing of bottles, pipes, bags, toys. The material, now you get an idea, whenever you look at the bottle, what kind of plastic it is polythene. So polythene is, this is all about polythene. Next one is polythene completed. Next one is PVC. PVC stand for polyvinyl chloride. Vinyl chloride, polyvinyl chloride, PVC. So PVC is generally formed, PVC is generally produced by heating. It is heating technique. PVC is generally produced by heating water emulsion of vinyl chloride. See, it is preparation includes preparation in the self. It is generally produced by heating of water emulsion. I already explained emulsion in the colloids and solution topic. Water emulsion of vinyl chloride, which is called as monomer. So this vinyl chloride is a monomer in this. Vinyl chloride monomer in presence of benzyl peroxide. Benzyl peroxide. In presence of benzyl peroxide under high pressure. See, polyvinyl chloride is one of the type of plastic which is abbreviated as polyvinyl chloride. It is generally formed by heating of water emulsion of vinyl chloride. It is a chemical compound. Vinyl chloride reacts with in the presence of benzyl peroxide at high pressures. Then the formed product is called as PVC, that is polyvinyl chloride. So now I am writing what is meant by vinyl chloride, how it is forming. C double bond C HCl. This is vinyl chloride. This is vinyl chloride monomer unit. This vinyl chloride undergoes heating. Heating is generally denoted by delta in the presence of benzyl peroxide BP and high pressure. Then the finally formed product is called PVC. That is like this. The double bond will be broken and it forms like this. HCl. H. So this is PVC. I hope you understand. PVC is a polyvinyl chloride. By heating water emulsion of vinyl chloride in the presence of benzyl peroxide at high pressure produces PVC. Now coming to the properties. Properties of PVC. One is colorless. It doesn't possess any color. It is odorless. Odorless means it has no smell. It is colorless. It is odorless. And finally, it is inert. Inert in the sense it is unreactive. It is inert. Inert in the sense PVC cannot be interacted with anything. It cannot be reactive. It is highly unreactive. So it is called as inert. And it is also brittle. Brittle in the sense we can mold easily. So these are the 4 properties of PVC. And PVC uses, I am writing uses here. PVC uses is as follows. It is generally used in sheets, generally prepared sheets, helmets, refrigerators. See, this is all about PVC, this preparation, these are the properties. Uses includes, it is widely used in preparation of sheets, used in the helmets what we are wearing, and is also used in certain kind of refrigerator. Some parts of the refrigerator also made up of plastic. In that plastic, the PVC is also one more important component. Now we are moving on to polythene is completed, PVC is completed. We are now moving on to Teflon. Now Teflon. Teflon is one of the very interesting plastic. Teflon is also called as fluon. Teflon is also called as fluon, or Teflon is also called as fluon. It is also called as polytetra, is a common name. Polytetra fluoroethylene. This is the name of Teflon, actual name. Tetra. Teflon is also called as one of the plastic which is also termed as fluon or polytetrafluoroethylene. It is obtained by polymerization of polytetrafluoroethylene. Tetrafluoroethylene is a monomer unit in this. By the polymerization of tetrafluoroethylene, it is written as like this. The structure is C double bond was C, F fluorines, all are fluorines. Tetrafluoro N forms here the single bond in the presence of same again benzyl peroxide. In the presence of benzyl peroxide, the monomer unit is tetrafluoroethylene. 1, 2, 3, 4 tetraethylene. The single bond will be broke and it forms same fluorines as it is. This is called as Teflon. So this is how the Teflon is usually prepared. And the properties of Teflon in the sense, here when you observe Teflon, the Teflon contains 4 fluorines. Many fluorines atoms are there. We know that fluorines are high electronegative. It has a capability to attract the substances or the components towards itself. So because of that reason, which are very tough. So it has properties in the sense, properties includes which have high density. It has high density because of 4 fluorines. It has high density and extreme toughness. Toughness. High density, extreme toughness is one of very important properties of Teflon. And uses of Teflon includes, generally it is used in glass fibers, for the preparation of glass fibers, stop clocks, and certain kind of materials called as gaskets. It is very important. It is a kind of material, gaskets. So these are the 3 important uses of Teflon. And one more important thing is also, it is also used in transformers. So this is all about Teflon. This is preparation of Teflon, properties of Teflon. These are the uses of Teflon. This is all about Teflon. Now polythene completed, PVC completed, Teflon completed. Now we are moving on to polystyrene. Simple polystyrene is nothing but, polystyrene is formed by polymerization of monomer called as styrene. It is formed by polymerization of styrene. I will explain with the formula of styrene, how the styrene, for example, this is styrene, C double bond C, this is benzene ring, here H, this is one monomer unit, this is called as styrene. It undergoes polymerization to form polystyrene, single bond like this, again C, many H. See, this is how, this is a one styrene monomer unit which is undergoing polymerization to form many units, which is called as polystyrene, because many styrene units are combining. Polystyrene. And properties includes, first property, it is transparent. Unlike polythene, transparent. We can clearly see through this material. It is transparent and it is excellent moisture resistant, same as polythene, excellent moisture resistance. One is, first property of this polystyrene is it is transparent in nature. Second one, it is excellent moisture resistance because it is hydrophobic in nature. The moisture cannot be inculcate or impermeable, permeable through this. And one more thing is chemical resistance also. Chemicals also cannot destroy the polystyrene. Chemical resistance. Chemical resistance, transparent, excellent moisture resistance and chemical resistance. These are the properties. And uses in the sense, generally used in lenses. We know that our eye lenses are generally made up of this material that is called as polystyrene. Second one is battery cases. Second one is battery cases, and third one is combs. Generally we use combs. In that also this material is used. Now this is all about preparation of polystyrene. This is the properties of polystyrene. These are the uses of polystyrene. Now we have completed polystyrene, polythene, PVC, Teflon. Now we are moving on to urea formaldehyde and bakelite. What is meant by urea formaldehyde? Urea formaldehyde is nothing but it is generally formed. First, urea formaldehyde. Urea formaldehyde preparation is, urea formaldehyde is also one of the plastic. It is generally prepared by the reaction of urea. This is urea structure. NH2, NH2. Urea in the presence of HCHO. This is formaldehyde. Urea reacts with 2 moles of formaldehyde to forms urea formaldehyde. NHCH2OH. NHCH2OH. So this is urea. This is formaldehyde. Urea reacts with 2 parts of or 2 moles of formaldehyde to forms. This is called as urea formaldehyde. This is a reaction. This is how the urea formaldehyde will be forms. And properties of urea, it has properties includes properties. First property is it has good tensile strength. Good tensile strength. Tensile strength in the sense it can contract indefinitely. It can elongate itself. So it is called as good tensile strength. And one more important property is good chemical resistance. Good chemical and also moisture resistance. Chemical and moisture resistance. And also it is very light in nature. It is lightest of all plastics. So these are the various properties of good tensile strength, good chemical moisture resistance and light in nature, which is very light to carry. So these are the properties. And uses includes generally used as binders. Binder in the sense which are used to combine two materials in the formation of glass fibers. It is used as binders. It used as cation exchangers. Cation exchangers. It also used as cation. And it is also one of the very important application is it is used in decoration items. Decoration items. Decoration items. So these are the uses: binders, cation exchanges and decorative items. These are the uses, these are the properties, this is a preparation. Now we are moving on to bakelite. Now we are moving on to bakelite. Bakelite is also very important. It is an example of thermosetting plastic. Thermosetting plastic. It is an example of thermosetting plastic which is very hard. Generally be useful in electronic devices. This kind of plastic is used. It is usually formed by the polymerization of phenol plus formaldehyde. Phenol reacts with formaldehyde to form bakelite. Phenol reacts with formaldehyde to form bakelite. This is a preparation of bakelite. And properties in the sense it is heat resistance, it cannot catch heat, That's why we are using it electronic devices. It is electrical insulator. It is also one of the very important application. It acts as insulator. That's why we are using this material especially in switchboards, electronic gadgets. And one more important thing is it will become hard on heating. Whenever we heat this material, it will becomes very hard. This is one of the property of this. And now uses includes, first use is electrical appliance. It's a primary important use. It is generally used in electrical appliances. Electrical appliances are generally made up of this plastic. Second one is pens. We are using pens. This material also bakelite. Third one is toys, jewelry, and we are also used it in washing machines. 4, 5. So it is generally used in electrical appliances, pens, toys, jewelry, washing machines. So these are the important uses of bakelite. These are the preparation. These are the properties. This is all about different types of plastic. Different types of plastic. Now we are moving on to compounding and molding of plastic. This is very interesting and simple topic. Compounding and molding of plastic, in the sense, the plastic is a material. We can mold the plastic according to our use. Mana avasaram anugunanga we are molding it. How the molding can be happen means, plastics can be molded because of some constituents. These constituents contain or derived as resins, plasticizers, fillers, catalysts, stabilizers. In the preparation of plastics, these kind of molding agents are generally added. ఈ agents add చేయడం వల్లనే plastics అనేవి ఈజీగా మౌల్డ్ అవుతూ ఉంటాయి, because of presence of molding agents such as resins, plasticizers, fillers, catalysts, stabilizers. So with the help of this thing, the plastic can be molded or fabricated according to our usage. So this is all about compounding and molding of plastics. The next topic is natural rubber or vulcanization of natural rubber. What is meant by rubber? We know the rubber. We are using a rubber for many years, and rubber is nothing but high polymers. Natural rubber are nothing but which are high molecular weight polymers. High molecular weight polymers. Rubbers are generally called as which are high molecular weight polymers with elastic properties. Which are elastic. They can be contract. Elastic with properties. Elastic properties. Basically, it is high molecular weight. It possesses elastic. It can extend like this. This is elastic. Rubber can be extend like this. So it is called as elastic properties. And generally, natural rubber, in the sense, it contains basic material called as latex. Generally, natural rubber is made up of a material called as latex. Latex, it contains a monomer unit called as isoprene, which is very, very important in this. I am repeating again this. Natural rubbers are two types: natural rubber, synthetic rubber. In the natural rubbers, the basic material is latex. Latex is one kind of substance in which by which the natural rubber is formed. The latex contains a monomer unit called as isoprene. This isoprene is one of the compound. By number of isoprene repeating units, the rubber is formed. That is isoprene unit. And this structure generally in the form of like this: double bond C, double bond C, C, C. So this is how isoprene ring will be absorbed. By repeating units of these isoprene units, the natural rubber will be formed. And the molecular weight of natural rubbers is approximately 100,000 to 1,50,000 daltons. This is the weight of natural rubber. Rubber generally weight as this much, 10,000. 1 lakh to 1,50,000 molecular weight ఉంటుంది ఈ న్యాచురల్ రబ్బర్కి. అండ్ వన్ మోర్ థింగ్, ఇట్ ఈస్ జనరలీ ప్రొడ్యూస్డ్ ఫ్రమ్ ప్లాంట్స్ సచ్ యాజ్ హీవియా బ్రెజిలియన్స్. So generally the natural rubber is natural, that means it is abstracted naturally from plant source, from a plant called as Hevia brasiliensis. Hevia brasiliensis అనే ఒక ప్లాంట్ నుండి ఈ రబ్బర్ని మనం ఎక్స్ట్రాక్ట్ చేస్తుంటాం. అందుకే దీన్ని న్యాచురల్ సోర్స్ వస్తుంది కాబట్టి ఇది న్యాచురల్ రబ్బర్ అని మనం అన్నాం. నౌ దేర్ ఆర్ సమ్ కైండ్ ఆఫ్ డిసడ్వాంటేజెస్ విత్ ద రబ్బర్. రబ్బర్కి కొన్ని ప్రాపర్టీస్ ఉంటాయి, అవి డిసడ్వాంటేజెస్. ఆ డిసడ్వాంటేజెస్ని అవాయిడ్ చేయడానికి ఒక టెక్నిక్ ఉంటుంది. ఆ టెక్నిక్ ఈజ్ కాల్డ్ ఎస్ వల్కనైజేషన్ రబ్బర్. వల్కనైజేషన్ ఆఫ్ రబ్బర్ ఈస్ ఇట్ ఈస్ అ ప్రాసెస్ జనరలీ యూస్డ్ టు ఇంప్రూవ్ ద ప్రాపర్టీస్ ఆఫ్ రబ్బర్. రబ్బర్ యొక్క ప్రాపర్టీస్ని ఇంప్రొవైజ్ చేయడం కోసం యూజ్ చేసే టెక్నిక్నే వల్కనైజేషన్ ఆఫ్ రబ్బర్ అంటారు. వల్కనైజేషన్ ఆఫ్ రబ్బర్ ఇన్ ద సెన్స్ ఇట్ ఈస్ జనరలీ యూస్డ్ టు ఇంప్రూవ్ properties of rubber, to improve properties of rubber. So to improve the properties of rubber, generally this vulcanization happens. What will happen in the vulcanization? Ante vulcanization lo em chestarante, the natural rubber is taken and this is compounded or binded with certain chemical compounds. Those chemical compounds are, example, hydrogen sulfide HS, and some other materials called as sulfur. Is also binded with sulfur mostly, and also benzyl chloride also used. Benzyl chloride. That means the natural rubber is binded with natural rubber. Natural rubber is binded with these kind of chemicals to improve its properties. So this happens within the vulcanization. Generally when you observe tire, we know that bike tires and car tires. If you observe the car tire which is made up of rubber, it contains approximately 3 to 5% of sulfur because of vulcanization. 3 to 5% of rubber is there in car tires. So this is all about natural rubber and vulcanization of natural rubber. And now we are moving on to elastomers. Elastomers are nothing but synthetic rubbers, are also called as elastomers. Synthetic rubbers which are not naturally extracted or isolated, but in the laboratory by man-made it is synthetically prepared. So these are called as elastomers. This is all about elastomers. An example for elastomers are many types are there. For example, polyester. This is an example for one of the elastic. We are using polyester. This is also example of elastomer. Now preparations of uses of bunaies and rubber, neoprene rubber. I think this is a concept which is not in your Ecet syllabus right now. So right now we are skipping this topic. Now we are moving on to fibers. Fibers are nothing but thin layers which can be elongated indefinitely, which have more strength. With the help of these fibers we can manipulate the things very easily. ఫైబర్స్ అనేవి ఏంటి, ఇట్లా తీగల్లాగా ఉంటాయి. దాని ద్వారా మనం ఏం చేస్తాం, కాంప్లెక్స్ మెటీరియల్స్ కూడా ఈజీగా లోడ్ వెయి చేయడం కోసం యూజ్ చేస్తూ ఉంటాం. సో దీస్ ఫైబర్స్లో ఎస్పెషల్లీ 2 types ఆఫ్ ఫైబర్స్ ఉంటాయి. ఫైబర్స్ ఆర్ 2 types. ఎగ్జాంపుల్ ఇన్ యువర్ సిలబస్ నైలాన్ 66 one type. Second type is polyester. Polyester and nylon 6, these are the 2 important fibers which have been discussed in your syllabus. And coming to these things, already we have clearly explained what is meant by nylon 6 is, how nylon 6 is prepared. We already discussed in the first chapter. You can go through that nylon 6. And polyester is generally prepared. I am explaining this polyester. This is prepared generally from reaction of terephthalic acid. Terephthalic. I am not explaining nylon 6 because I have already explained how the nylon 6 will be prepared in the first early hours. Adipic acid plus, in that nylon 6 explanation is already completed. You can go there and check. This is polyester, reaction of terephthalic acid plus ethylene glycol. Ethylene glycol. So due to the reaction of terephthalic acid with ethylene glycol, the formed product is called polyester. The structure is as follows. This is called as terephthalic acid. C double bond OH and C double bond OH plus ethylene glycol. This is ethylene glycol OH. Then as a result of polymerization of these two, here polyester will be formed. And coming to these are the polyester, we are used in very many occasions. Our cloths and laundries, textile industries, in such kind of things, the polyesters are widely used because of various properties. And preparation uses of nylon 6 we have already discussed it. Now, biodegradable polymers and their explanations. What are biodegradable polymers? We have discussed about polymers. I have already said plastic polymers are not that much degradable in the soil. That's why it is a major cause of soil pollution. Soil pollution అవ్వడానికి మేజర్ కాజ్ ఏంటి అంటే ప్లాస్టిక్. అందుకనే గవర్నమెంట్ అనేది స్ట్రిక్ట్ లాస్ అండ్ రెగ్యులేషన్స్ని ఇంప్రొవైజ్ చేస్తుంది. ఎందుకంటే అక్కడ ఉన్నటువంటి పాలిమర్స్ బ్రేక్ డౌన్ అవ్వాలంటే మిలియన్స్ ఆఫ్ ఇయర్స్ పడుతుంది. అందుకే ఇన్ ఆర్డర్ టు రీప్లేస్ ద ఎగ్జిస్టింగ్ పాలిమర్స్, biodegradable polymers are polymers. Biodegradable polymers means the polymers that can be degradable by living organisms such as bacteria can be easily degradable by bacteria, simply bacteria. Special kind of polymers can be bacterial action. So these are the special kind of polymers which are environmentally friendly, which can be easily degradable after the అవి వాడిన తర్వాత బ్యాక్టీరియల్ యాక్షన్ ద్వారా ఈజీగా డిగ్రేడ్ అయిపోతాయి సాయిల్లో. సో దెర్ ఈస్ నో ఛాన్స్ ఆఫ్ సాయిల్ పొల్యూషన్ విత్ biodegradable polymers. General applications includes, most of the times it is used in medical applications. In the medical instruments it is used, that is medical applications. Medical applications. One more important use is food packaging. In the case of food packaging also we are generally use this thing. So these are the two important things. Easily degradable by bacteria, which use in medical applications, and food packaging. These are the different types of biodegradable polymers and various properties of biodegradable polymers. Next we move on to bakelite is manufacturing of, we know that, I think bakelite is manufactured by the reaction between, I already explained, phenol plus formaldehyde. So this is Ecet 2024. Urea and formaldehyde is not, phthalic acid and ethylene glycol is also not, ethylene glycol and formaldehyde not, phenol and formaldehyde I have already given example for this. Next one, which of the following is an elastomer? Bunized rubber. Melamine is an example for, is also one of the form of bakelite, so it is not answer. Dacron, it is not there in your syllabus. Polystyrene is an example for plastic, so the remaining answer is bunized rubber is the answer. Bakelite is prepared by condensation polymerization of simple, again came same answer. The gas that is responsible for Bhopal gas tragedy, methyl isocyanide. This is a methyl isocyanide formula. You have to remember this. In the 1984, in the year 1984, Bhopal gas tragedy happened. Because of leakage of this methyl isocyanide, it has happened. Still, the people at that Bhopal incident are suffering from radioactivity. So this is all about methyl isocyanide. The trade name of the polymer coated non-stick utensils is Teflon. Under the brand name Teflon అని వాడుతుంటాం. Teflon కి ఆల్రెడీ మీకు చెప్పాను. It is also called as Fluon. It is also called as polytetrafluoroethylene. అటెన్సిల్స్లో ఏంటంటే మనం నాన్ స్టిక్ ప్యాన్స్ వాడుతూ ఉంటాం ఫ్రై చేయడానికి, అక్కడ ఒక బ్లాక్ కోటింగ్ లేయర్ ఉంటుంది. దట్ కోటింగ్ లేయర్ ఈజ్ నథింగ్ బట్ టెఫ్లాన్. సో దిస్ ఈజ్ 2024. Octane number of petrol that consists of 20 is 2, N-heptane and 2,2. It is out of syllabus. It is 80. So you have to remember this because it is not at all discussed in your syllabus right now. Bakelite is an example of very simple thermosetting plastic. I already explained. It is very hard. So it is very, very easy. It is without any doubt. It is bakelite is an example of thermosetting plastic. Which of the following are monomers of butyl rubber? Butyl rubber means, I think this is the answer. So this is the answer. And now So this is thermosetting plastic, okay, and this is all about polymers, and you have to go through all the polymers and various classifications of polymers. And finally, I am very happy today, and because I have delivered the lecture very well, and I hope you understand this topic very well. And myself, Chandra Prakash, Faculty of Chemistry, Ecet, Ask Engineering Academy, Dilsukhnagar. If you want to join the academy, you can get through the details in the link box provided below. And thank you so much for giving me this wonderful opportunity. Thank you so much. All the very best for exams. Thank you so much, students, for listening my class very patiently.